this lesson, we're going to look at a different technique other than using trial factors, and this technique is called grouping. So it's very similar to what we saw in part 1, which was lesson 3, but with a little bit of a twist. So what we need is we need to find two numbers, p and q, that satisfy the following two properties. We need p plus q to be equal to our middle term, and we need the multiplication of p times q to be equal to the product of our first coefficient and our last term. If we can find the numbers p and q that satisfy these two properties, what we do is we decompose our middle term, which is bx, into a sum of px plus qx. Once we decompose like this, then we use the grouping technique to factor this quadratic expression. So let's go ahead and revisit those three examples that we saw in the last lesson and see how we can use this different technique to factor those trinomials. So in this case, we're looking for two values, p and q, that add up to our middle coefficient, which is the number 7, and they give us a product that's equal to a product of my first coefficient and my last term, so a product of 6. So can you think of two numbers that add to 7 and multiply to give us 6? Yeah, those two values have to be 6 and 1. 6 plus 1 is 7, and 6 times 1 is 6. So what we do is we break up our middle term, which is 7y, into a sum. 6y plus 1y. Okay, these new values that we get of 6 and 1 are the numbers that we get from p and q. And then, after we've done this, we use the grouping technique to try to find a binomial factor up here. So, in our first two terms, so let's group together these two and these two. In our first two terms, we could take out a factor of 2y, and we're left with y plus 3. In our second group, there is really no common factor here, so I'm just going to put them together as y plus 3 inside a brace like this. So hopefully it's easy now to see that each term shares a binomial factor of y plus 3, so let's remove that. And we're left over with 2y plus 1. So here's our fully factored form of this quadratic expression. In our second example, we have 3x squared minus 16x plus 5. This means we're looking for two values, p and q, that add together to give us negative 16, and whose product is 3 times 5, which is 15. So can you think of two values that we can add to get to negative 16, and two values we can multiply to get to 15? This one's a bit trickier, but with a little bit of work, you can see that p is negative 15 and q is negative 1. If we add together these values, negative 15 minus 1, we get negative 16, and if we multiply them, negative 15 times negative 1, we get the value of 15. So this tells us if we want to use this particular technique, we're going to take our middle term, which is negative 16x, and break it down into negative 15x minus x. And then we're going to group together our first two terms and our second two terms, and hopefully this will all work out beautifully. So factoring out a 3x from our first one, we have x minus 5. And now we get to use a technique from a couple chapters ago. See here how we have x minus 5, but up here we have negative x plus 5. So let's factor out a minus 1. If we factor out a minus 1, this changes the sign of our two factors inside our binomial factor. And now we have that common binomial factor of x minus 5. So we can bring that one out, and we'll be left over with 3x minus 1. Now, just to switch it up a little bit to make things a bit more interesting, let's take a look at this example where we have 10t squared plus 11t plus 3. Now here we know p plus q has to add up to be 11. And p times q must be equal to the product of 3 and 10, which is 30. So can you think of two values that we can add together to get 11 and multiply together to get 30? Well, those two values are 5 and 6. 5 plus 6 is 11, and 5 times 6 is 30. So this tells us that if we want to factor this particular quadratic expression, we could break up our middle term and rewrite it as 5t plus 6t. And then we're going to group together our two pairs and work on common factoring. So inside of our first pair, we could factor out 5t, and we're left with 2t plus 1. And in our second pair, we could factor out a common factor of 3, and again we get 2t plus 1. So our common binomial factor is 2t plus 1, and then what's left over is 5t plus 3. All right, my little epsilons, stay positive.